The moon is running away from the Earth. How can we stop it? Why orbiting objects get tidally locked. What makes more sense, repairing Hubble or replacing it? And in Q&A Plus, did the solar system produce its own interstellar objects? All this and more in this week's Question Show. It's time for the Question Show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down, I'll gather them up, and I will answer them here. All right, let's get into the questions. Jake Gajoff. What are the main causes for making an orbiting object in a solar system tidally locked versus spinning? So tidal locking is this inevitable event that happens given long enough time and if two objects are close enough together and something is irregular. So what happens is, and we'll sort of use the example of the Earth and the moon. So the moon is in orbit around the Earth, and the Earth is pulling at the moon is pulling at the Earth, and the Earth is sort of pulling a different amount on the moon on its front versus the back, because the back of the moon is farther away from the Earth than the front of the moon is. And so this causes an elongation of the moon. It kind of turns it into something that's like a little bit of a flattened sphere. It used to be the moon was much closer to the Earth than it is today. And so the moon was rotating, but it was being pulled differentially on these, what I like to call handles. And so you get this torque effect on the moon from the gravity of the Earth. And so the moon would just be slowing down and slowing down and slowing down. And eventually the orbit of the moon would just stop. It would be tidally locked to the Earth. And this is the same effect that happened to all of the Jovian moons. When you hear about all of these exoplanets that are tidally locked to their stars, it's the same process. And in fact, the moon is causing the Earth to try to be tidally locked to the moon. So the moon's gravity is pulling on the Earth. It's causing a bulge, a tidal bulge on planet Earth. And these are handles that the moon grabs onto as the Earth is rotating sort of under its gravitational field. And it is slowly trying to slow down the rotation of the Earth. And because you need to have this conservation of angular momentum between the Earth and the moon, as the Earth's orbit is slowed down, we lose, I forget what it is, like a couple of milliseconds every century, the moon drifts farther away from the Earth to compensate. And in about 50 billion years, the moon will have slowed down the rotation of the Earth to the point that now the Earth and the moon are both tidally locked to each other. But of course, the sun will have been burnt out, and probably the sun will have consumed the Earth at that point. But you see that with Pluto and Charon. So you've got these two objects that are roughly the same-ish scale, and they're tidally locked to each other. So tidally locking is the natural effect. And so sort of an interesting flavor of this, it really all just depends on your altitude of the object that is orbiting around the moon above the larger object. And so the Earth takes 24 hours to turn once on its axis, while the moon takes 28 days to do one orbit around the Earth. And so because the orbital time of the moon is longer than the rotation time of the Earth, the Earth slows down and the moon drifts away. But if the moon is orbiting so quickly that it is orbiting more rapidly than the orbit of the planet, then you get the inverse. So the moon speeds up the orbit of the planet and the moon draws in closer to compensate. And the example of this is Phobos, which is orbiting around Mars. So a day on Mars is a little over a day on Earth. It's like 24.5 hours to orbit, but Phobos only takes about 8 hours to do one orbit around Mars. And so now this torque, this tidal effect caused by the interactions of the gravity of Phobos and the gravity of Mars works in reverse. Phobos is going around faster than Mars is, and so it's grabbing onto those handles, and it is pulling Mars to orbit more quickly and more quickly and more quickly. And to compensate, the orbit of Phobos is degrading. Then eventually, in about 50 to 100 million years from now, Phobos will cross the Roche limit, get torn apart, and then rain down on the surface of Mars. So yeah, any two objects orbiting around each other that, if there's any kind of way for them to be torqued, they will tidally lock with each other. Philip, how do we stop the moon from getting farther away? We have to stop the rotation of the Earth compared to the moon. So if we could slow down the rotation of the Earth to the point that the Earth and the moon were tidally locked to each other. The moon is tidally locked to us, but if we were also tidally locked to the moon, then the moon would no longer be drifting away from us. Leaf binder. If moon tickets were only $500, would you go see it? Absolutely. Yeah. Yeah. If I could take a flight to the moon for $500, done. Sign me up. If I could take a flight into low Earth orbit for $500, I would probably, like, if it was safe, like airplane safe, fly me to the moon, $500, sold, I'm on board. But it's not. It's hundreds of millions of dollars right now. So unfortunately, it's too expensive. But if you offered me a $500 ticket to go to Mars, I probably would turn you down, because a trip to Mars is 3 years, high radiation environment, incredibly dangerous. I would love to teleport, to take the Stargate to Mars and stand out on the surface of Mars in my spacesuit and go, whoa, I'm on Mars. How crazy. This is cool. And then teleport home. And going to the moon is roughly that. Like, yeah, you got to take a couple of days to get to the moon. You stand on the surface of the moon. You're like, I'm on the moon. And then you come home. But to go to Mars or other places is just such a long journey. I don't think I would want to do it. I'm happy that other people want to do it, and I will cheer them on, but I'm not that guy. It's time to shout out our new patrons at the $5 level and above: Daniel C., Jesse of Astoria, Eric E., Jack Markham, Simon, W. David Woods, Anthony Della Carpuccini, Eric, S.A. Bremner, and Wild Zero. Join our community at patreon.com/universe today. CeeLo 87. Is the cost to send a repair update mission for Hubble greater than a new Hubble-sized telescope, considering the military discount mirrors that NASA got? Right, so there's a whole bunch of questions that you're kind of mashing here together. So the first thing is, like, what would it cost to repair the Hubble Space Telescope? And, back in the day, there was the space shuttle, and the space shuttle flew, and it was able to do servicing missions for the Hubble Space Telescope. And I don't know the price of the servicing missions. They were in the couple of $1 billion range, which is what the space shuttle cost to be able to do flights, 500 million to a couple of billion, depending on what the cargo was and what the mission was doing. So let's say that it's $1 billion to service the Hubble Space Telescope. That means to fly a space shuttle, dock with the Hubble Space Telescope, upgrade the instruments on board, replace any of the gyros, any of the parts that could be reaching the end of life, and then give it a boost to raise its altitude again so that it has many more years to go. That's a lot of money, but it is definitely less money than it cost to build the Hubble Space Telescope in the first place. And that's why they were doing the servicing missions. But now we don't have the space shuttle. Space shuttle doesn't exist. And now we don't have a spacecraft that is capable of doing servicing in the way that the space shuttle did. It had the robotic arm, the Canadarm, that was able to grab onto the Hubble Space Telescope, bring it to the bay of the space shuttle. They were able to go out from the shuttle and be able to perform the docking operations. And then it was able to release it again on the higher altitude. But a couple of years ago, Jared Isaacman, actually, who's the new NASA administrator, pitched to NASA that they would like to do sort of a private partnership mission to repair the Hubble Space Telescope or service it. And they would use a SpaceX Crew Dragon, which is the same spacecraft that's used to deliver astronauts to the International Space Station, and that they would perform that operation on Hubble. And that it would, and I forget the budget, but it was like in the 500 million-ish range. And NASA said, thank you very much, but this is freaking us out, because that you're not having a spacecraft that really has the docking bay that's really designed for this kind of operation. You've got people docking on a Crew Dragon, doing spacewalks, trying to perform these repairs, where they're going to keep the spare parts. And the concern was, what if it accidentally bumps, causes any damage to the Hubble Space Telescope? And then this would be a big problem, because now you wouldn't get the remaining years of Hubble, you would have less years. And building a new Hubble telescope would be very expensive. And as you said, NASA got the 2 donated Hubble class mirrors from the National Reconnaissance Office. One is in Nancy Grace Roman, and it's launching in 2 months, so don't use that one, but they still have the other one. And so, like, could they theoretically build another Hubble Space Telescope around that other mirror? Yeah, they could, but they don't have the budget for that. That all of the future budget is going to different scientific priorities down the road. So you've got the main big flagship mission is going to be the Habitable Worlds Observatory. And that is going to be a James Webb class. So a 6.5 meter mirror which is much bigger than the 2.4 meter mirror that was in the Hubble Space Telescope. So it all comes down to a lack of funding. That if NASA had unlimited funding, then I'm sure somebody would say, well, let's just make a partner to the Hubble Space Telescope, something that can fly after Hubble and continue on with that mission because Hubble is oversubscribed. But then, like, why make a replacement for Hubble? Why not build another telescope that can go out to the L2 Lagrange point like the Habitable Worlds spacecraft or James Webb or these kinds of next generation flagship missions? So it really just comes down to budget. Like, what would it cost to build a replacement Hubble? It would be a few $1 billion. Let's say $4 billion to build another Hubble. Or you spend $1 billion to repair Hubble and sort of see if that gives you more life on it. But really, NASA doesn't have either of that funding. They have the funding potentially, maybe someday, to build the Habitable Worlds Observatory. They have very limited options. The Mars sample return mission was canceled. The administration recently tried to cancel dozens of missions. So this is not the time that NASA's like, I wonder if we could just like build another Hubble. That'd be cool, right? They just don't have the budget for it. That said, the Chinese Space Agency is building their version of the Hubble Space Telescope, which is going to be around the same size as the Hubble Space Telescope. They're going to be sort of flying it in formation with the Chinese space station. And so when they need to service this telescope, they'll have it maneuver in, dock with the station. They'll be able to spacewalk out of the station, do their repairs, and then send it off. And so it's going to be roughly the same size as the Hubble Space Telescope, but it's going to have all of the modern instruments of 2026 as opposed to instruments of 1990 that have been repaired and upgraded since then. Aaron929. Fraser, is there best direction to look for meteors if one is quickly looking at the sky? Planet ecliptic, forward direction of the Earth's travel? So it depends on the meteor shower that you are attempting to see. So in fact, the meteor showers are named after the constellation where they appear to originate. So the Perseids meteor shower appears to originate from the constellation Perseus. The Geminid meteor shower appears to originate from the constellation Gemini. The Leonids appear to originate from the constellation Leo. And you can see this, like if you know where your constellations are, then you can go out at night and you can sort of watch that constellation and you will see the meteors are coming out like a star coming out from that central region. But you don't have to be watching that region to see the meteors. They'll happen anywhere in the sky. It's just that if you sort of trace the line back, you would end up at where that spot was. But there is a general background level of meteors that are happening all night, every night. And so if you just like go out any single night, any time of the year, look up and wait for about a minute or two, you will see a meteor. And that is the background level. And so generally when astronomers calculate the meteors per hour that you could see from any one meteor shower, they're sort of like, what is the additional meters that you see above and beyond the background? And those can come from any direction. It's interesting, sort of early on in the night, like just after sunset, you get a specific class of meteors. So you get these sort of much longer meteors that will like leave a very long trail, and they're really cool. So often it's good to start looking for meteors even like shortly after sunset. And then sort of right in the middle of the night, you can get ones that come in almost directly. And so you don't get the big long streak. You almost get this sort of explosion in the sky because you're looking face on to the meteor that is coming in. So, but yeah, you can see a meteor any night. You don't like, if you want to see a meteor, find dark skies, watch the sky for a while with some friends, hang out, and you'll see meteors. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? And we call it Q&A Plus. And this week's bonus question, did the solar system produce its own interstellar objects? I'll put a link in the show notes. All right, those were all the questions that we had this episode. Thank you, everyone who joined me for the live show. Everybody who put your questions into the YouTube comments. We're getting close to the beginning of the hiatus. I think there's going to be at least, or maybe at most, one more live stream before we're off the live streams for the summer. But I'm going to explain how this whole hiatus thing works in a second. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Carolyn, Chuck Hawkins, Commander Baylock, Dark Fingers, David Gilton, David Matz, Enthrall Reading and Math for Toddlers, Evan.Pro, James Clark, Jerry Matter, Jim Burke, Jordan Young, Marcel Sitz, Michael Purcell, NASA Ocean Guy, Nordspace, OneServeAnimals.org. Please follow my nephew at VBrick6994, Rinkaidu, Richard Williams, Sean Sargent, Stephen Falamundi, Team 49, Telescopes Canada, Vlad Zeppelin, Wolfgang Klotz, Zelda, Fraser will say anything for $100, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. If you've been following this channel for a few years, you know that we go on live stream hiatus from the end of June to the beginning of September. And that just means that we aren't doing the various live streams every week that we traditionally do for the rest of the year. And we used to do a lot more live streams. And so really where this affects this channel specifically is the Monday question show that I do 5 p.m. Pacific to 7 p.m. Pacific every Monday. And so I do all the shows all the way around the year, and then we won't do 8 shows. So over the course of July and August. And I mean, the reason we do this is that when you are sort of scheduling to do live streams every single Monday, as well as the other live streams that you do, you're kind of tied down. And during the summer, you can't go visit people, you can't go camping, all this kind of stuff. You're just kind of stuck. And so when the weather is the best, and when I kind of need to gear down a bit, that's the perfect time that we do it. Now, we're still going to be producing essentially the exact amount of content. You won't notice any difference if you're just kind of a casual viewer on this channel. We'll still do Space Bites every week. You'll get all the news. I'm still doing tons of interviews, so you'll see lots of interviews coming into the channel. We still release question shows. It's just that we're releasing them from the additional material. We record a 2-hour show every Monday, and we only put out 1 hour every week. So we've got tons of additional material that has never been seen, apart from if you've watched the 2-hour live streams. That stuff will come out normally. And then this is the time when I try experiments. I try new stuff. So the big project that I'm working on right now is that I'm building a sort of a DIY smart telescope. So, you know, the C-Star, the Vespra Pro, the Dwarf Mini. So I've got all of these smart telescopes, but I'm very constrained by the software that I have to use to be able to run these telescopes. And so I have been working on developing a system that allows me, sort of gives me all of the control that I want. Direct connection to the telescope. I can move it around the sky. I can stack live. It looks like a smart telescope, behaves like a smart telescope, but it doesn't have any of that software that comes from any outside producer. It's just completely customized for what I need to do. And it's totally designed to allow me to live stream. And so over the course of the summer, I'm just going to be trying to test it over and over and over again and try and work out all the bugs and smooth down the process and just make it more and more a delightful experience to both operate the telescope as well as for people to be able to watch it. And then the kind of the long-term plan for this is that I can bring in guests and I can let them operate the telescope while we talk about what we're looking at. So, but it has to be easy to use. And the progress has been incredible. I mean, we are at the point now where I'm really sanding off the rough edges. And so I will be doing a lot of live streaming over the summer to just kind of get this process going. So the other thing, I've got some other show ideas, sort of focus on a topic that I want to try tackling. So, you know, one of the nice times about hiatus is that this is my chance to just experiment and try new things and sort of think more blue sky. Now, we're, of course, still going to be reporting like crazy at Universe Today. 40 to 50 stories a week. We're producing the podcast. We are doing all of the work. It's just the live streams. And that counts for both what I'm doing here on the channel as well as the Astronomy Cast. So Astronomy Cast goes on hiatus July and August, and then we're back again in September. So hopefully that explains the process. It's going to, you know, things are going to get weird over the summer, but hopefully you will stay incredibly entertained and stay on top of all of the cool space news. All right. We'll see you next time.